Hi everybody, this video explains Le Chatelier's principle, which is the principle that Tuesday night's lab addresses. So Le Chatelier's principle states that if stress is applied to an equilibrium system, the system will shift to relieve the stress. So what that means is if you have a reaction system, such as this reaction here, that's in equilibrium, the double arrows indicate the equilibrium, it means that if there's some sort of stress applied to this side of the equation, it will shift to the right. And what that means is that it would produce more products. If the stress were applied to this side of the equation, it would shift to the left side of the equation, meaning that it would give up its products to produce more reactants. And the idea of the shifting equilibrium back and forth is to always satisfy the equilibrium expression, because K is a constant, and as each one of these parts of the fraction or the equation change, another will change proportionally according to the expression, so that it will always equal this K value. So when we talk about the stresses applied to an equilibrium system, we're going to talk about two of them right now. One is changing number of moles, so that's the first one I'll talk about. So if I were to change the number of moles by, let's say, increasing the moles of N2, so if I add more moles of N2, the result of that is going to be that the equilibrium will shift toward the products, shift to the right, meaning that it will produce more of the product, and in turn it would end up decreasing the amount of the other reactant. So increase one reactant, the other reactant decreases, equilibrium shifts to the product side, and you end up with an increase in the number of moles of that product. Now let's try something different. Let's say that we decrease the moles of hydrogen gas. So if I decrease, so my stress is a decrease in the amount of hydrogen, so if I decrease the amount of hydrogen, what happens is that the NH3 is going to move in this direction. In other words, the reaction moves in this direction. So some of this is given up to fill up the deficit that I've created here. So this will consequently decrease, and this would increase, because as this shifts over to the left, dropping off some hydrogen to fill up for the deficit, it's also going to have to give some more of that hydrogen. So that's another stress that can be discussed relative to equilibrium stresses. And then another one would be increasing the heat on an exothermic reaction. So for an exothermic reaction, we know that the energy term is on the product side. So if I increase the heat on an exothermic reaction, the equilibrium is going to shift to the left. So kind of like the number of moles, my stress is applied here. It's going to force the reaction over to the left. As it forces over to the left, it's going to decrease the amount of the NH3 and result in an increase of these two reactants. Again, always trying to satisfy this K expression so that the values change with the conditions in order to satisfy the K value. And then the other scenario would be if I were to decrease the heat. So if I decrease the heat, it works a lot like the changing the number of moles. If I decrease the amount of energy, it's going to want to create more energy, so it's going to shift over here, and as it shifts over here to fill up for that energy deficit, it's going to be producing more of that product, and in order for more product to be produced, these two reactants are going to decrease. And again, those values will change accordingly in order to always satisfy the K. I hope that was helpful.